G'day guys, you're back with Miracle Max. Today in the workshop we have something a little different. We have a Kawasaki KLE 500 2006 model. What's wrong with the beast? Well, it's just not charging. The battery goes flat constantly. What's wrong with it? I don't know. Let's figure it out together. The customer told me that they haven't had this bike very long. The person that they bought it from stated that they've replaced the battery already, and yet it still keeps going flat. Every time she goes home, which is about, I don't know, 20 minutes away, something along those lines, the battery goes flat. She has to put it on charge the next day just to get back to work. So is it an alternator fault? Is it a battery fault? We really need to examine it. Don't replace parts, don't guess, let's diagnose. So as mentioned today, she's travelled about 45 k's, and yet look, the battery's absolutely fantastic. There must be nothing wrong with this whatsoever. No, let's check a little further. Just because the battery says it's got good voltage right at the moment. I think she also said that she replaced this battery with her dad's battery last night, so it's got a fresh battery. It's got a new lease on life, but we really need to test the battery itself. Let's do a battery test on it itself. First of all, I'm going to start it up and bring up the revs, and of course we should see our multimeter reading going from about 12.9 up there up to about 14 point something. So let's just start it up and see what happens. We're not seeing any change there, are we? So the alternator's really not doing its job. So this little battery here is probably in not bad condition simply because she's driven that 40 something kilometres with not much or no contribution from the alternator. This is interesting. It's saying state of health 100%, state of charge 98%. Really, if it wasn't charging, we would surely see some sort of state of charge not happening here, and it's listed as a good battery. Time to investigate just a little bit further. I've disconnected this connector here. This one goes from here up to our regulator over this direction, and this here goes down to my alternator. So this design has a permanent magnet as a rotor, and the stator is stationary, and we can actually develop voltage even without anything connected. So they're made up of 3 phases all told. There's 3. Get back there, fella. And we can check individual phases. So you can see that there's 3 yellow wires down here. I'm going to check between the phases. So in other words, between this yellow and that yellow and that yellow, then that yellow and then that yellow. So we should end up with the same sort of voltage. And we should have roughly about 60 volts across the board. If we get 60 volts across the board, that should indicate to us that our alternator is functioning correctly. We need to look elsewhere, perhaps the regulator or rectifier situation. We'll check that next, but let's have a look at the voltage output of this guy over here, our alternator. For starters, I've got the phase that's on this side of the plug, so these 2 over here. I've just got a rag over there so it doesn't play up against the bike frame at all. So let's start it up about 1500 RPM, and we'll have a look at the voltages produced. So we need to turn it on to AC because that's what's being produced. AC volts. Let's have a look at what's being produced. We're up to 25. Let's bring those revs up and see what we get. That there's about 4 grand, and we've got 60 volts. Okay, I've shifted my plug, so I'm over this side. This is the second phase that we're on. Let's have a look at the readings. 4,000 RPM, we're hitting about 60 volts. And now for our third phase, we just go rit, up to the top one there. Okay, we're ready for that same test once again. So 4,000 RPM, and we're getting 60 volts. Okay, so what does that tell us after the test? It tells us that the rotor, the magnetic or the permanent magnet section of things is okay. It's not cracked and broken and flying off. The stator, the windings are okay. There's no shorts between them simply because we're getting the voltage that we require. And of course, if we look at our spec sheet, not that way, dopey. It says that it should be about 60 volts at 4,000 RPM. That's exactly what we've got. So I know that the alternator is okay. What's our next step? Next on our diagnostic checklist, we're heading toward the rectifier, that guy right there, also known as a regulator. Does both jobs actually, but we come down to the connector over here and you can see that there is a black yellow wire, that guy there, and there's a white wire right next door to it. I'm just going to hook up my voltmeter to that and see what sort of readings we're going to get. Now, of course, this should be our output, so we should be getting about 14 to 15 volts once we bring the revs up, we put it under load, etc. So that's our second test. Let's start it up and see what happens. Now, clearly you can see already it's not doing anything. Headlights are on. Yeah, nada. She's pretty much verschnookered, mate. All right, what's our next test? All right, so we get rid of that. We now need to disconnect this bloke here. Man, that's tight. There we go. All right, finally got him apart. Now we're going to be testing this side of it, so we're checking the regulator itself. We've already checked the alternator, that direction, so we need to check this direction. See the little short lead there? That's what we need to check. On our multimeter, we're not going to be stuck in volts anymore. We're going to go over to our diode range over here, and we're going to press our little button there. You should get a diode symbol up the top there. So that's what we'll be testing next, our diodes. Hopefully I've got the light off this little meter a little bit better. Now we're going to be going, that one there, between those yellow leads. Remember the yellow leads that we had over at the alternator? Similar ones. So as you can see here, they're all on one side. So you're going to go in between that one and that one. And we've got no reading. We're going to turn it around the other way. We should have a reading. We get no reading whatsoever there, folks. To this one and this one, we should have a reading, which we do. So you can see that's our forward bias voltage there. Whoops. And we can see that that's okay. We should switch him around the other way and we should get no voltage whatsoever between that fella and that fella. Okay, that's good. And then we should go between that fella and we should get some sort of voltage, which we don't, between there, and we do. So between this phase over here and here, we're getting nothing. And between there and there, that's it's got a blown diode inside the rectifier there, guys. So yeah, we need another rectifier. That fella is verschnookered. So the next test, we need to see if there's any shorts internally in the rectifier itself. Now this big black wire is our earth wire. So we can shove him in there. We need to go between the phases and that and see if there's any resistance. No resistance there, no resistance there. Oh, look at that, hey? That's a dead short, okay? Between one of the phases, and that would explain the blown diode, of course. We've got a short, as you can see there. So that says 0.03, that's only on that particular phase. Nothing there, nothing there. So I feel pretty confident that we need a new rectifier. This puppy is not happy. Just keep in mind, any sort of short, electrical short, will create heat. It will create less resistance, higher current, and therefore extra heat will be created because of this lower resistance. Now I'm going to use my thermal camera. You may have seen me use this before in other videos, particularly finding electrical faults, and I've just had a look myself and it shows up like a sore thumb. Now the problem might be is me trying to get back to the camera as quick as possible because this thing heats up fairly quick. So just bear with me while I try and keep this in frame for you. We'll just reach over to get the key there and we'll start him up. See that? Look at that hot spot, hey? Well, that's very clear, isn't it? We definitely have an internal short in the regulator. Okay, diagnosis confirmed there. We don't need to guess. We don't need to just replace parts. We need to inform the customer that they need a regulator or rectifier. It's built into the same little pack here. There's no physical heat. I can't feel any heat in there, guys. So this thermal camera is a great diagnostic tool. Guys, you're probably saying, come on, Max, I don't have a thermal camera. I can't afford one of those. Fear not, little people. I have a trick for you. We go from our negative side. This is our voltage regulator once again. I've got the ground wire, this black wire, as you can see here. I hope you can see it. That goes down to a wire, and that wire goes onto the negative side of a random battery. On the other side of the battery, the positive side, I'm going into a globe. And from that globe, on the other side of my globe, I'm going to stick it into those phase wires that we talked about. Remember, there should be no short whatsoever. So keep an eye out for this globe here, and I'll see if I can hold it for you at the same time when I stick it into these little connections here. So, well, the light doesn't come on there. That's one phase. There's another phase. And there's our third phase. Wow, look at that. Clear indication that we have a dead short within this voltage regulator. I've priced one. I'm just about to ring the customer and let them know the damage. Okay, so we've diagnosed this faulty regulator, and I've looked online at various forums, etc., and they've said, have you bought a genuine one or a non-genuine one? You can pick up these things for next to nothing, cheap as chips. But look, if you want something good, you've got to pay for it. I've spoken to the customer about it, and she's agreed to get the genuine item. So here we have it. I waited about a little less than a week, and there is my genuine item. So let's have a look at it and see how it compares to our old one. Make sure that we have the correct one. Sit them side by side there, Max. Looks all good. Now I have checked this previously, of course, and all my colours are correct. So bolt pattern, all that sort of gizmo. I supplied the VIN to the Kawasaki dealer. They were able to supply me the correct one. Yes, it was a bit more, but hey, if you want something reliable, well, you're going to have to go genuine in this particular case. These non-genuine ones tend to fail, apparently. So let's plonk this on and see if we've sorted the issue. It's not a big job to replace it, and as you can see while I was waiting, I've already pulled off the old one here. It was easier just to remove the coolant overflow bottle here. So one bolt there, easy access for the regulator bolts there, and then you just plonk it straight into this guy. So by the magic of video editing, and hey presto, it's now in place. But the more important question is, have we sorted the issue? Let's do some further testing. Look, I'm pretty impressed with this battery. It's held its own, 12.8 at this point in time, but hey, it's not what the battery is saying right now with the engine turned off. We want it to charge. So we should be looking at 14.345, something along those lines, to make sure that it's being charged correctly. So let's start her up and find out what it's doing. So even at dead idle, it's heading toward the 14 volt range, which is good. Bring the revs up, of course. That's up near our 4 grand, 14.4, something along those lines. That's good news. According to our specs here, we see that it should be between 14 and 15 volts. Now this, it states up here with the headlights turned on and then turned off. Now I don't think this model has the option of turning off the headlights, but we can go from high beam to low beam, that's for sure. So let's try that. 14.5, high beam, low beam. That's pretty good, isn't it? That's about 1800 RPM too, so it's not bringing the revs up too high, yet it's doing its full charge at that point. That's good news. Okay, I just got to take it for a quick spin up the road, make sure everything's safe. Then I can ring up the customer and let them know the good news. There's another one done and dusted, a faulty regulator on a Kawasaki KLE 500. It was good to see the diagnostic path point directly to that faulty regulator, including that thermal camera. I hope you got something from this video today, guys, and if you haven't already, please subscribe to the channel, give it a like, and feel free to comment down below. Of course, don't forget about that notification bell. You don't want to miss any future videos. Catch up with us on Instagram as well as Facebook to keep in the loop. So until next time, guys, this is Miracle Max signing off. I will catch you later.